Hello, this is Mr. Win, and this video is about multiple angle formulas, the half angles, double angles, the power reducing formulas, the product of sum formulas, and the sum to product formulas. There's a lot of formulas here, or identities to use. So first, let's talk about the double angle formulas. A double angle is twice an angle. We have three of these. So let's talk about sine of 2x. Well, that's the sine of x plus x. The last video showed you about the sum and difference formulas. So let's do the sum formula. That's sine of the first times cosine of the first plus cosine of the first times sine of the second. That's the same thing, so it combines as 2 sine x cos x. Right, cosine's a little different. Well, same idea first. Cosine of 2x is really cosine x plus x. Do the formula. You get that. Cosine x minus x is cosine squared x. Then sine x minus sine squared x. So that's one of the formulas, but we could use one of the Pythagorean identities. We can use cosine squared x equals 1 minus sine squared x. So I plug that in. I get this. Combined terms, I get this second alternate formula, same thing. Then there's one more identity we could use, this other one. Plug it in. Get this. Distribute the negative 1. Oops. And then combine like terms, you get this. So cosine 2x has actually three formulas you can choose from. Doesn't matter. I like this one more. I just think remember the opposite of the Pythagorean identity. Tangent is pretty simple. Tangent of x plus x. And you do the tangent, the sum of tangent formula from before. Tangent x plus tangent x combines to 2 tan x. The bottom is tan x and tan x is tan squared. So 1 minus tan squared. So those are three. You do need to know them. Here's the same three in a easier form, less clutter on the screen. But sine of double angle is this, tangent of double angle is this, cosine of double angle gives you any of these three, your choice. Alright, so first solve 2 cos x plus sine of double x equals 0. Well, we want to rewrite it so that everything is angle x, not 2x. Then we're going to factor and solve. So there's the original problem. Sine of 2x, I'm going to use that one formula, 2 sine x cos x. Then from here we can factor out 2 cos x. And what's up be 1 plus sine x on the inside. Set them equal to 0. The first one, you get where's cosine x 0? That's pi over 2 and 3 pi over 2. Where's if you subtract 1, where's sine x negative 1? You get 3 pi over 2. That's for within 0 to 2 pi. If I want the general solution, I'm going to add 2 pi n to each. Alright, that's a repeat. 3 pi over 2, 3 pi over 2. Alright, actually, since they are exactly 180 from each other, I can actually combine these two and just say it's pi over 2 plus pi n. Same thing. Alright, we're going to use the double angle formula to rewrite this. And we're going to sketch it. So, 4 cos squared x minus 2. We can factor out 2, and we'll have this left over. 2 cos squared x minus 1, you may recognize as cosine 2x. So, we now know that this equation, 4 cosine squared x minus 2, is the same as 2 cosine 2x. We can use our techniques from before, A, B, H, K. A is 2, amplitude is 2. B is 2, so that affects the period. It'll be 2 pi over 2, which is pi. Alright, there's no horizontal shift. Midline stays 0. It's cosine, so it's going to be high, mid, low, mid, high. Here's some important information, but here's the graph. So I said high, mid, low, mid, high, then it repeats. And it's pi for one cycle or period. Alright, use the following information. Find sine of double theta, cosine double theta, tangent double theta. So cosine theta is 5 over 13. And we are in quadrant 4. So actually, I draw the picture first. Remember, I put the dot in quadrant 4. I draw the right triangle. Our angle is really this right here. X is positive, Y is negative. The radius is always positive. They say you can tell that sine of this angle is O over H. It's negative 13, so it came from the picture. Then we do all the double angle for it. So sine of double theta is really 2 times sine theta cos theta. So 2 sine of theta, we know it's O over H, that's negative 12 over 13. And then cosine theta is A over H, that's 5 over 13. Multiply, combine like terms, and reduce. Reduce, multiply, and reduce, get that. cosine double angle, same thing, we use 2 cosine squared theta minus 1. So we can do 2 without cosine, it would be 5 over 13, but they square that. So 5 over 13 times 5 over 13 is 25 over 169. Then minus 1, do common denominator, and then combine, you will end up with negative 119 over 169. Then for tangent 2 theta, we could do the formula, or we could be smarter and actually just say that tan theta 2 theta is just sine 2 theta over cos 2 theta. That's the quotient identity, right? So we just use this divided by this. Now they skip the step, but it's fraction divided fraction. That's fraction times fraction. Negative divided times negative is positive, so it's going to be positive 120 over 119. Alright, the double angle formulas are not restricted to just angles like 2 theta or theta. We do any other combinations. We could also say like 4 theta and 2 theta or 6 theta and 3 theta. So, you know, I change sine of 4 theta into 2 sine 2 theta cos 2 theta because 2 theta plus 2 theta is 4 theta. So over here, even for cosine for 6 theta, we can say it was 3 theta 3 theta. Or they use this cosine squared minus sine squared 1. But by using these forms together with the sum formulas, we can actually do other multi-angle formulas. So here's a famous triple angle. Sine of 3x is really sine of 2x plus x. Then I do the sum formula to get this. Then I'm going to do the double angle formula for sine of 2x. Turns to that times cosine x. Then here I'm going to do the double angle formula here. Here we know cos x is cos x is cos squared x. And here we could distribute. Yep, they did it both at the same time. Then I do the identity for cos squared x, Pythagorean identity, to 1 minus sine squared x. They're going to distribute this. And last, they're going to combine. So sine of 3x is really equal to 3 sine of x minus 4 sine cubed of x. Alright, we also have the power reducing formulas. The double angle formulas can be used to obtain the following power reducing formulas. And we're about to do example 5, but it's something that we use in calculus. If you notice, cosine of 2 theta, if I go back, I can actually solve for sine squared. Right? I actually use this one, so I could subtract the 1, divide negative 2, and actually get this. So I can actually go from a formula with an exponent to a formula with no exponent. So that's called reducing the power. Alright, so we could solve it for sine, solve for cosine, and then for tangent, I just divide these two by each other, and the twos cancel out, you'll get this. So it's pretty easy to prove. But anyways, we're going to rewrite sine to the fourth of x as the sum of the first powers of cosine to multiple angles. Alright, we're going to do a lot of power reducing forms, so notice that. So first we're going to change sine to the fourth into sine squared squared. Then we use our sine squared power reducing one to get this. Right, then that's going to be squared. Then we're going to FOIL this actually to get this, and they actually FOILed and they took out the 1/4. Then we're going to do the same thing and repeat it. We're going to do this cosine 2 theta, cosine squared of 2x. We're going to change into 1 plus cosine 4x over 2. So we do the power reducing formula twice, and there's no more exponents. We're going to distribute this 1/4, and then just reduce, combine, or whatever, factor out. We know this. So sine to the fourth x, this is fourth power, has no exponents here, it's all first power stuff. Or we have half angle formulas. We can use that from the power reducing formulas, just change all the angles u to u over 2, and the sign depends on which quadrant we're in. Alright, so here we'd say find the exact value of sine of 105. Well, 105 is half of 210. So we can say sine of 105 is equal to the formula where I put 210 in here. You should know the cosine of 210 on the unit circle. They chose to use reference angles, although that's not necessary. And they found out it was actually root 3 over 2, or really negative root 3 over 2. Negative is positive. Then you work with that, and that's our final answer. I think this is next. Alright, they chose a positive square root because sine theta is positive in quadrant 2. 105 degrees is in quadrant 2. Alright, now if you type this in calculator, sine of 105, you get this decimal. If you type square root of 2 plus square root of 3 all over 2, you get the same decimal. Alright, here's the same thing for solving. So first you write the equation. They changed cosine of x over 2 squared, remember that's cosine squared x2, into this all squared. We square power of square root, whether it's positive or negative, you just get that square root cancels out, just the positive version. Here the 2's cross out. Then they did the Pythagorean identity for negative sine squared, or root for sine squared, and they distributed negative 1 in a second. So they distribute the negative 1, combine like terms, move things over. Here you can factor out cos x, and you get cos x minus 1. Set them both equal to 0. You'll get these three answers from 0 to pi. If I wanted the general solution, I would add 2 pi into all three of these. And actually, these two are 180 apart from pi apart. I should say pi over 2 plus pi n, and then 0 plus 2 pi n. Alright, a few more with the product sum formulas. Each of the following product sum formulas is easily verified using the sum difference formulas discussed before. So actually, I just work on the right side. If you did the difference for cosine, difference or sum for cosine, distribute combined terms, it'll turn into this. However, there's 4 of these you have to know. Just look at how they are. Anyways, here we'll try it. Rewrite the product cosine 5x times sine of 4x as a sum or difference. We recognize that from before. Cosine times sine is this last one. It turns to this 1/2 sine of the two angles added minus sine of the two angles subtracted. So 1/2 sine of the two angles added minus sine of the two angles subtracted. Fix that inside. That's 9x. That's 1x, and you distribute the 1/2. That's it. One step, or 2 steps really. We also have the reverse. Sometimes we don't want to make a product into multiple terms. We want to make multiple terms into a product, so we can change to sum to product. So here's these formulas. Alright, so here we have a sum of cosine 195 and cosine 105. Those are not nice angles. Although you could actually break this down to 2 of our sum formulas. There's lots of ways to do this. So let's do the faster way first. We could recognize it's the appropriate sum to a product. We can say if you have cosine plus cosine, that turns into 2 cosine of this times cosine of that. These inside fractions, 195 minus 105 is 300, divided by 2 is 150. 195 minus 105 is 9 divided by 2 is 45. You know the cosine of 150, you know the cosine of 45. Multiply all together and reduce, you get this. However, I could have made this a sum. I could change this cosine of 135 plus 60, and this is cosine of 60 plus 45. I would have had 4 things, but it would have eventually turned to this. So lots of different ways to do this. Alright, here solve sine of 5x plus sine of 3x. So write the original, do the sum of the product formula, simplify each, and that's it. Now to solve, set each factor equals 0, so 2 sine 4x equals 0, and set cosine equals 0. You get all of these. Also, if you had cos x equals 0, you get nothing new. So really, it's everything over 4. So you say x equals pi n o all over 4. And here's the graph if you're curious. It's every pi over 4. 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, and so on. Alright, last, verify identity. Right, last, yep. Sine t plus sine 3t over cos t plus cos 3t equals tan 2t. We'll just work on the left side. You can use, for the top, use the sum of the product formula. For the bottom, do the sum of the product formula. Fix the insides. Then here, notice that is really, the top is really sine of 2 double angle, bottom is sine of a cosine double angle, and then that turns into tangent of that double angle. And that's it. Hope you enjoyed the video. Make sure you ask some questions in class. Thanks for watching. See you soon. Bye.